Let's do this malware reverse engineering challenge. We'll take a look inside the malware and find the flags. So let's do the challenge. Let's start the attack box. I'm going to open the attack box in a new window. Let's do the first challenge. What we'll do is download these task files. This is actually the malware inside a zip file. So if we click on it, you'll see it starts downloading on your own computer. And of course you want it inside the attack box. So what you can do is right click, copy download address, then go here, type the command wget, that's the download command, quotes, paste in the link, put the end quote, select all, Ctrl C, and then open a terminal, right click paste and press enter. So that downloads the malware to a computer. You'll see we downloaded it, and if we open the home folder, you'll see we have this zip file. You'll see strings1 blah 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 .zip and so on. So let's rename this to a better name. We'll just call it strings1.zip and then remove all that junk at the end. So let's just rename it strings1.zip. And this, if we try to open it, which is a zip file, if we try to open it, you'll see we have this strings1.exe. That is the actual malware program that we'll analyze. So we'll click extract, put it in the root folder and click extract. And now it's going to ask you about the password. So the password is actually given in the room in the introduction section. And the password of the zip file is malware tag. So if we type that password and click OK, you'll see the file has been extracted. And now if we close this, we have the malware on the computer, strings1.exe. Now for the first challenge, they ask us, the executable prints an MD5 hash, so that's a digital fingerprint or a flag, on the screen when executed. And can you grab that flag? They also say you don't need to run the executable. Now running it is also not possible because this program is a Windows program. You'll see here .exe. If I get the file information, you'll see this is a Windows program, Intel blah 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 for MS Windows. Now on the attack box on this computer, we're on a Linux computer, and these programs, Linux and Windows, they are not compatible. So we can't run it. But that's also an advantage when you do malware analysis, that the malware cannot run on the program on the computer you're using to analyze it. So that is a big advantage because then your own computer cannot be infected. So how can we analyze this? So there's a command we can use, which is the strings command. And this is going to take a look at any readable text inside the program, anything that looks like readable text. So we specify the file name. So like this. Let's maximize it and press enter. And you'll see I made a typo with the file name. So strings with the file name and you might press enter. It's simply going to output everything that looks like human readable text. And as it's a computer, it's also outputs some gibberish. So if we scroll up, you can see some human readable text. Now, nothing here that looks like a flag. They want to find the flag. So if we scroll up, we find a lot of flags here, but we don't know which ones, right? So there's a lot of decoy data. So we might need some heavier equipment to analyze this malware. We see so many possible flags, and we could try them one by one, but we have more to do. So let's close this, and then we'll open this program in a malware analysis or a reverse engineering tool called Ghidra. So we go to Applications, BinX, and you'll see this tool Ghidra. So if I start this, you'll see this tool with their cool logo or dragon. It's going to pop up and takes a moment to start up. But once it's started, we can load in that executable and then possibly find the flag. You'll see it's booting up. You'll see this logo. And it takes us a second to set up. There's going to be a bunch of windows to configure that it starts loading. So this we can do close. Then we go here. We do File, New Project. And this is going to be a bunch of windows before you can actually look inside the program. Click Next. Give some name to this program. So to name it strings1. That's the challenge name. Click Finish. Then we need to actually load the program. So we click File, Import File. and we click on that program. That's the .exe, Windows executable. So strings1.exe, select file to import. You see it's importing. Now, it's not going to be ready right away. We have another screen, and there's going to be a bunch of those pop-ups. So we click OK. So it's now loading something, and then it's importing that file. You see it's reading the file, and it gives some information about the file. So it's when it is last modified, it's for Windows, what type of computer, and so on. So some basic information is printed. We click OK. That's another pop-up. Then what we need to do is double click here. So double click on the file name. You'll see that little dragon pop up. And then, as you might expect, there's going to be another pop-up. So here we go. It says that the file name has not been analyzed. Would you like to analyze it now? We click yes. And we click analyze. And now we are finally done with all those pop-ups. You see with the progress bar here, it's analyzing the file. And then we can literally look inside the program, meaning we can see the program code, which is both in assembly and the C computer code. So in the programming language C, we can read the program, and it's also split by logic. So the program is going to have many functions, and we can take a look inside the function of every code. So you can go here, functions, and make this thing full screen. And you'll see we have a function entry. So let's double click that. And once we move this to the side, what we see here is the start of the entry function, then some text, and it's calling the MD5 hash. Now remember, they ask us which flag did the MD5 hash get generated. So we have the MD5 here, and now I double click, so let's go back. And here we see the flag. Flag, can I take it, make it any more obvious? So that is the flag. Now, let's copy the flag command. So we say right click, copy. Then we go to this little pop-up and we copy it. Now, if we paste it in, you'll see the last character is that tilde or the curly brackets. So in here, it doesn't end with the curly bracket, but with these two characters. So let's change it to a curly bracket and see if it accepts that as a flag. And you'll see it didn't accept that. So we could take a look at this this flag. Could take a look inside with the strings commands. Say strings with the file name. And then let's search for that anymore. We'll see if we can find that command. So the cruel flag is, can I make it any more obvious? That somehow here got cut off. So let's copy this one, right click, copy. And then we copy it from the clipboard and we paste it in. And there we go. We've completed the first challenge. On to the next one. Okay, so we click download task files for challenge 2. Then it starts downloading it, and then we download it to our computer. So let's download it to the attack box. We copy the download address. Then again, we type wget. We paste in the commands. Put the closing quotes. Open a terminal. Right click, paste, enter. And you'll see it downloaded to the attack box. Now let's take a look at it full screen. And again, for this one, they want us to know the flag. It says this executable prints an MD5 hash to the screen. Can you grab the flag? So once this thing is loaded up, we can go to the home folder and you'll see this strings2. So let's rename it. We just want to have it named strings2.zip. Then we extract it, or we open it with this viewer, extract, click extract, and then the password is going to be malware tag with capital M and capital T. Click OK, and it tells us it's a wrong password. Let's double check. So it does seem to be malware tag, but let's try again. Okay, it doesn't. Let's try to, it has a question mark at the end, so that's a little error here. Let's right click, rename, remove that question mark, right click, extract here, then we type that password, click OK, and you'll see we got the program strings2.exe. That's the actual program. We see some gibberish here, doesn't have the icon, so let's remove that to avoid confusion. So we have this program strings2.exe. Now we could take a look with the strings command inside that file to see what we find. So you can say strings and then the program name. And let's see, it's strings2.exe. And you'll see we can find a bunch of data. So if we scroll up, we see in this case there's not a lot of decoy data, but also there is no flag visible in here, right? So there's a bunch of data, unless this is the flag, but otherwise there doesn't seem to be any thing specific. So let's open this program in Ghidra, the reverse engineering tool. So let's close this and let's close this one as well. We go to applications, BaneX, and start Ghidra. So it takes a second to load, and then we'll do the same steps to load in the program. So we click close, we click file, new project. Next, it's going to be named strings2. The next challenge, the next malware to analyze. Then click on the program and click file, import file, strings2.exe. Select file to import, click OK, then it's loading it and we'll see it appear below here. Once it is imported, you see it's importing right now the program, click OK, you'll see the file is now here and we need to double click to look inside it. So if we don't do anything, it's actually not doing anything, we need to click twice, double click. Then it's gonna open up the screen showing the computer code for that program. So we'll say that has not been analyzed, the string2 program, click yes, starts analyzing it, click analyze. See this little load bar at the bottom, so it's analyzing it. And of course, we are interested in these functions here, in the entry function, because they mention in this data here that it prints the MB5 hash with the fingerprint on the screen, and this fingerprint is generated from a flag. So let's take a look. We go to functions, and click, let's actually make this bigger. Let's click entry and you'll see we have a lot of variables here, local2 and many others. And then here we have F, some hexadecimal format variables. And then they call here this MB5 hash. That's going to be what is shown on the screen. And as an input, they use this local2c. So this local2c is a pointer into C, that is this thing, and then it's all those variables are after that in the memory, right? So you have all these variables and probably combined they make up the flag. So we could actually take a look at that in CyberChef. So we could say copy all of this. We can do copy. So then if you take a look at it, you'll see this F and all kind of hexadecimal values after each other. So what happens is that they have this pointer to it, that is a memory pointer, points to that memory address. So of the 2C, so you see local 2C, memory address points here. And then it's simply gonna input everything that comes after that, because it's pointing, it's hashing whatever comes after that from that starting point of 2C. And these are all hexadecimal formats. So like you have different formats, decimal, binary, 0 and 1s. You have hexadecimal that starts counting from 0 to F or 0 to 16 if you're being literal. And so you see all these values are in hexadecimal format. Just like a value can be in binary format, it can be in decimal format, in hexadecimal format, and so on. These are in hexadecimal format. And what we can do with a tool like CyberChef is to convert them back to readable text. So I copied all of this and then removed all the gibberish around it. So I removed all the local is and the 0x and the semicolon. And then you end up with just the hexadecimal numbers. And then what you can do is in CyberChef, you can say from hex. So it's going to convert from hexadecimal into readable text. So the flag seems to be something like stack strings are the best. And we can actually take a look at it. Let's check with the strings command. In the strings command, there is not. So probably this is the flag. Stack strings are the best. And probably the first letter is the F. That is this one that's between quotes, is not hexadecimal. So we have flag, stack strings. I don't know if they're underscores or normal dashes. Stack strings are the best. Brackets, we click check. And you'll see we are very close, but this is not the correct flag. So there's something after here, -s. And probably there's going to be something more after that. What we could do is take a look. So it's going to say here 7D, that's the last character. And you'll see something went wrong with my typing. So it's going to be 53, where we have still 53, then 54. We have 52, 49. And 49. So when you do this manual with CyberChef, you see it can make some errors. So we have 49, then 4E, 47, 53, and 7D. And there we go. This is the flag. Stack strings are the best strings. So we go back to this room, and now we've removed the extra flag in front. So we click check, and there we go. We have the challenge completed. So on to the third challenge. So in the third challenge, we again have to do something that gets converted to a digital hash, which is MD5 fingerprint, and the input is the flag. So we again need to try to grab that flag. We need to download the executable. So let's download the executable. Then we do right click, copy download path. We go to this little box here, remove everything, wget, quote, and inside paste that link. Copy it, then open a terminal, right click paste, enter. So it downloads the malware tree. The malware into this computer is again going to be the zip file. So if we go to this root folder home, we have this strings tree, rename it. So make sure to remove all that gibberish. So it's strings3.zip. Now we can extract it. So to extract it, we simply double click, then we click extract, click extract, and we type the password malware tag, capital M and capital T. Let's make sure we type as correct. Click OK and click close. Then in the home folder, we now have strings3.exe. Now let's take a look at it with git directly. Let's skip the strings command because we couldn't do it the last two times. Let's close this thing. We click File, New Project, Next. We call it strings3, Finish. Then we import the executable. We click File, Import File, strings3.exe. You see here, strings3.exe, that's the malware we'll analyze. And click OK. Then we see this little screen. It's again a Windows malware. Click OK. And then we double click on the file to take a look at the computer code of this program. We click yes and analyze. Now it's going to take a second or so to analyze the program. And you'll see something else here. Click OK. So now let's take a look at the functions as always and see if we can find something. It doesn't really. Okay, simply selecting. So we click on the entry function, that's the start of the program. Sometimes it's main, sometimes it's entry. So make sure you click on that entry. Let's see if we can. And then we see the actual source code. So we see. So inside this code, you'll see we found the entry function. This is where the program starts. There's see a bunch of variables. None of that really matters. And then you'll see it has this MD5 function with local N9. You'll see that it's just a bunch of characters. Then they call here find resource function, and they say here rc.rc. This is a resource. Typically, programs can store icons and other stuff inside the program in the resource section. That is, you'll see the program tree. You'll sometimes have this rsrc, that is the resource section. Now, if we double click on it and we scroll down, so we scroll all the way down. Sorry, I clicked on the wrong one. So rsrc. If we click on that and scroll all the way down, you'll see many flags, but as you might expect, most of them are decoy flags. Now, inside the function, you'll see if inside the program, they say load string. So a string is a piece of text. So they're loading a piece of text from address 0x110. So this is in hexadecimal, not in human readable format. So we can convert that. We can say 0x110 or 110, and we convert it from hexadecimal, and that's a 1-2. So you can say 1 to the decimal, and that's 272. Now inside this list, if we go to the section and then to the flag section, you'll see there are different blocks. So you see a bunch of those flags, and then there's another block. Scroll down, there's another block. Let's see, another table, and then again another table. So many different ones, and all of them, they are 16 flags long. So what we can do is we can divide this 272 to divide it by 16 to see which block number we need. So we need block number 17. Then if we need to actually start to count them. So we scroll down. So this is the first block, the second, the third, the fourth, the fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, but we start counting from 0 with computers. So let's go to the next one. And then we find the flag. So we copy this, right click, copy. Then we go to this section here. We copy it and we paste it in. And there we go. We now completed this challenge on basic malware reverse engineering.